Boys, today we're looking at multiplication of fractions, and we're going to start by using diagrams, and then we'll go on to just some standard questions. Okay, so let's have a look at this first question here. Number one says shade the diagrams appropriately to find the answer to the multiplication of each pair of fractions. All right, so 1a asks us to multiply a quarter times by a half. So if we think about the quarter first and we shade 1/4 of this diagram, now if we now shade a half of the diagram, so if we look at how I've split up the diagram, I've split it in 4 ways, sort of going across, and then 2 ways going up and down. So if I now do half sort of going across and shade half of it, when I multiply these two fractions together, I get the result of what's overlapped. And so if you can see there, what's overlapped between the two, well, it's just this block here, isn't it? It's 1 out of the 8 blocks, and so that would be the answer to that multiplication. So that's when I multiply a quarter by a half. Think about it a little bit differently. If I've got a quarter of this rectangle left and I halve that, then I'm only going to get one of those two. Alright, let's go to the second one, B. I've got 3/4 times by a half. So if we shade in 3/4 that way, and then we do a half this across ways, do a half, how many of them overlap? 1, 2, 3 overlap, so that one, and that one. So 3 out of 8. Let's look at C. A half times 1/5. So a half times 1/5, if I colour in a half. So again, crossways, it's a half. And then let's change colour, let's go to red. Let's do a 1/5. So if I go those two, that'll be a 1/5. So how much of those two does it cross over? You can see that it overlaps in 1 out of the 10. So the answer that would be 1 out of 10. Now there's a few more different questions here. I'd like you to have a go at those. I might just do 1 or 2 more. So particularly the ones that don't have the diagram drawn for you. So this one here, let's look at F, 2/3 times by 1/3. So if I split it into 3 this way, and split it into 3 going up and down, because it's both about thirds. Let's do the first color in blue. So if I now do 2/3 sort of heading across, that's going to be coloring in those 6 squares. Now if I now color in 1/3 in terms of up and down, that one there. So how many altogether are colored in, or sorry, are overlapping from the two? I can just see this square and this square, so that would be 2 out of the 9. So you basically break up the rectangle in relation to the setup. So if we just take this one H, you'd want to split it in 5 going across, 1, 2, 3, 4. Use a ruler if you've got one, and then 3 going that way. So then you'll be able to start your question. Alright, if we just have a look at question 2, it says evaluate each of the following using a diagram. Leave your answer in simplest form. In A, you've got a quarter times by 2/5. So again, if we split this into 4 and then into 5, we've got 1/4 in terms of going across. Two-fifths, two rows. So my grand total then would be, how many overlap? Well, there's just these two in the corner, so that's 2 of how many blocks are there altogether in there? Well, there's 20. 2 out of 20, which I can simplify to 1 out of 10. So you need to simplify. Every time you do any fractions question, you always ask, can I make it more simple? Can I simplify it further? Okay, so just give me one more example of how to simplify. Looking at, let me look at some different numbers. Some of these are going to need to split into quite a lot of blocks. So let's do C, 6 and 4. 1, 2, 3, 4, 5 and 6 across, and then 4. So it's going to be 6 times 4, 24 different spots. I'm going to go 5, 6 across, so all 5 up to there, colored in. Then for red, I've got 3/4, so 3 out of the 4. So how many cross over this time? Well, it looks like we had 6 going across and 5 of those. So it's basically going to be 5 times 3, it's going to be 15 that are colored in. So 15 out of, there's 24 blocks. Look for a common factor between 15 and 24. 3. So it's going to be 5 and 8. Fantastic. So that's how you use a diagram to solve these. And hopefully that helps you understand why when you multiply a number by a fraction, by a proper fraction, then it's going to make it smaller. So let's have a look at some multiplying fractions here on the next page, page 16. Multiplying fractions, whole numbers and mixed numerals. Okay, so let's start by thinking about question 1. Now, one of the things about multiplication is really just a repeated addition. So if I told you I had 5 and I was timesing that by 3, that's really the same thing as saying 5 plus 5 plus 5. I'm doing 5 and then I'm timesing it by 3. There's 3 lots of 5. Or you can think about it as 5 lots of 3. It's the same thing. 3 plus 3 plus 3 plus 3 plus 3, which all gives you 15. So if I apply that type of thinking to this next question, 2/5 times by 3, there's 3 lots of 2/5. So that's one lot, plus another lot, plus another lot. So there's 3 of them. 3 lots of 2/5. Now, knowing our addition of fractions, these have all got the same denominator. So we can just add the numerators. 2 plus 2 plus 2. So it's going to be 2 plus 2 plus 2 out of 5. Notice how the denominator doesn't change there. So it's going to be 6 out of 5. Or 1 1/5. So now I'm going to give you a rule that you can solve it with. So 2/5 times by 3. Another way to think about that question is 3 is really the same thing if I wrote it as a fraction as 3 over 1. And so the rule works by just multiply numerators and multiply denominators. So multiply numerators and multiply denominators. So if I do that, I get 2 times 3, I get 6 on the top. 5 times 1 on the bottom is going to be 5, which is 6 over 5, or 1 1/5, which is the same as what I got above. But I just used a rule this time. Okay, having a look at C. 2 times 3/4. Okay, so it's 2 lots of 3/4, so I can do repeated addition. 2 times 3/4. I've got 3/4 plus another lot of 3/4, which is really just 3 plus 3, that's 6 out of 4, or 1 and 2 out of 4, which is like 1 1/2. Okay, so using a rule, instead of approaching it like that, we could just say, well, 2 over 1, 2 is the same thing as 2 over 1, so I can just do 2 times 3, multiplying the numerators gives me 6. 1 times 4 gives me 4, which simplifies to 3 over 2, or 1 1/2, which is the same thing as what we had over there, up there. Alright, so moving now to a couple more questions that involve mixed numerals. Okay, well, first we'll do E, so 8 over 1 times 3 over 8. Multiply the top, you get 24. And multiply the bottoms, you get 8. 24 over 8, that's actually just 3. 3 wholes. Alright, F, the way we're going to do F is we're going to change them into improper fractions first. So changing the first one, we get 1 times 3 is 3, plus 1, that's 4 over 3, times by 14 over 5. Multiply the numerators, you get 4 times 14 is 56 over 15. And then you see if there's any common factors, and in this case there isn't, so that is just going to be 3 and 11 out of 15. Okay, looking at G. Okay, 3 1/2 is the same thing as 7 over 2 times by the second one, 29 over 7. Multiplying those two. What's actually interesting, before I just jump to doing that, if you notice, because I'm just saying I'm multiplying the numerators and multiplying the denominators, I could rewrite it like this. And what you notice is there's a factor of 7 on the top and the bottom. So I can actually just cancel those out, and I just end up with 29 over 2, or 14 1/2. Now before we finish up, just a reminder, if you're doing any fraction, 3 over 4 times by 2 over 5. To simplify that, you multiply the numerators, so you get 6. Multiply the denominators, you get 20. And so then you can simplify it, gives you 3 out of 10. Good luck with your questions.